Welcome to this complete guide to Web API in .NET 8 course. In this course, we are going to cover almost every aspect of ASP.NET Core Web API in .NET 8. And also, we're going to learn how to consume the Web API with an ASP.NET Core MVC application. So in the first section, we're going to learn about what and why. So what is a Web API? Why do we create a Web API? Right? How Web API works in theory. And then we're going to move on to the next section where we're going to cover some of the technical basics of Web API, such as routing, model binding, model validations, and return types, and action filters. After that, we're going to start implementing the endpoints in the next section. We're not only going to cover the CRUD operations like create, read, update, and delete, we're also going to work on validations with action filters and exception handlings with exception filter. Up to this point, we have been implementing everything with a in-memory repository, which help us to learn things quickly. In the next section, we are going to actually use Entity Framework Core to replace the in-memory repository. And after that, our Web API will be able to connect to the database, and we will be able to work with real data. In the next section, we will work on create a ASP.NET Core MVC application to consume the Web API. Just like before, we will not only work on the CRUD operations and just display the data, update data, create data. We will also work on creating a executor class to wrap around all of the mechanisms that we need to communicate with the Web API endpoints. We will be handling form validations, and we'll be handling errors and display errors on the forms. After that, we are moving on to interesting parts of securing Web API and consume the secured endpoints. We will be securing our Web API with JSON Web Token. I'm going to show you a complete workflow how the JSON Web Token works, and we're going to implement each of one of those processes that is involved in the JSON Web Token workflow. After that, we're going to consume the protected endpoints from our MVC application, and we're going to learn how to save and reuse the JSON Web Token and how to deal with expired token. And in addition to all of that authentication logic, we're going to learn how to use scopes for authorizations so that we can protect our Web API with different permission setups. And then we're moving on to Swagger document and API versioning. We're going to learn how to create Swagger document manually, and we're going to create different versions in the API endpoints. And after that, we're going to learn how to configure the Swagger document in order to support multiple versions. I hope you enjoyed this course, and feel free to look at the descriptions of the course and the free previews of the course. This is a new series, and in this series, I'm going to update my existing course on Web API to use .NET 8. In this first video, we are going to talk about what is Web API and why we create Web API. API stands for Application Programming Interface. And the purpose of an API is to help software applications or components interact with each other. So you would have application 1 or component 1 trying to interact with application 2 or component 2. So usually how do we do that? We use an API to facilitate the communication between the two components. But a Web API is apparently a specific type of API that allows two software applications or components to communicate with each other over the internet. So the only thing that is different is here, instead of just going through internally on the same server, Web API would help the two components communicate or interact with each other through the web. Let's look at an example why we want to create Web API. In the past, developers used to create monolithic applications. This means that the entire application was built as a single self-contained unit. All the different parts of the application, such as the user interface, business logic, and data access layers, were tightly coupled, just like this. They are tightly coupled together and run in the same process. However, this approach can become a problem when we want to run applications on different types of devices, such as web browsers, smartphones, smart TVs, or smartwatches. But if we want to stick with the monolithic approach, we would need to create different versions of the same application for each type of the devices. This can be a lot of work and can lead to duplicate efforts. Right? You can see that each different platforms would probably require different applications, provided that the operating system is different. They're usually different. So to address this issue, we can divide the application into smaller independent components. Right? Instead of let them tightly coupled together, we can separate them like this. Right? Separate them into UI layer, business logic layer, and data access layer. We can then pull some parts of the monolithic application out of the application itself and create a web API to combine these parts. For example, if we pull the business logic layer and data access layer out, and then we wrap these two in a web API like this, so we have business logic layer and data access layer pulled out of the monolithic application, and then of course the data access layer talks to database, and the business logic layer talks to the data access layer, and then we use web API wrap around it, right? And we deploy the web API onto a server. By doing so, we can make applications functionality accessible to different type of devices. Of course, to make this work, we also need to create different user interface applications, right? It's like the original monolithic application now only contains the UI layer, and then this application will have to be recreated as different versions to work in these different devices or operating systems. And then these applications would invoke the web API endpoints in order to get the functionalities. So by doing so, we can make the application more flexible and accessible to different type of devices. This can save developers a lot of time, as we do not need to create different versions of the same applications, right? Same monolithic applications for each type of devices. Well, let's consider another example why we create web API. Many companies collect large amount of data as part of their business operations. For example, social media companies, e-commerce companies, weather or location data companies, financial companies, or IoT companies, Internet of Things. These companies all collect significant amount of data, and this data is highly valuable. These companies often want to make it available to other developers to create new innovative services. To achieve this, companies can create web APIs that allow external developers to access the data. So you can just use web API to wrap around the data and then expose the data to other developers so that different services can be created, innovative products can be invented. So far, we addressed why we need web API, but what is web API in technical terms? So let's take a closer look at that. As we saw in the previous examples, right? API are usually created for two different scenarios. One is to share the data, which is the second example that we just talked about. And the other one is this example, which is the first one, that we're sharing the functionalities that is provided by the business logic layer. So first, we share data, this scenario, and the second, we're sharing the functionality from the web API. But no matter what the web API provides, the content is provided through functions, right? Think of them as similar to functions in programming language. But these functions, instead of being called by other functions in the same program, they are accessible over the internet and are usually called by other applications, typically through the HTTP protocol. So therefore, in short, web APIs are simply a set of remotely hosted functions, right? So these functions are not on the same machine and being called by other functions in the same program, in the same application, within the same process, but they are hosted remotely. So a set of remotely hosted functions accessible over the internet or over the web, typically through the HTTP protocol. That's the simplest definition I can come up with to technically define what is a web API? So in essence, web APIs are simply a collection of remotely hosted functions that can be called by other applications over the internet. This makes it possible for applications to share data and functionalities with each other, and it is a crucial part of modern software development. In this video, I would like to explain how a web API works in theory. Like I mentioned before, web API is usually used to either share data or to share functionalities. So let's use sharing data as an example to illustrate how web API works. We already know that in technical terms, web API is just a set of remotely hosted functions that run on a server. In our example, these functions access a database to share the data. And typically, data operations include create data, read data, update data, and delete data. These are so-called CRUD operations. In order to make these functions be exposed outside, we have to create a web API application. A web API itself is a type of application that runs on a server. So let's use this rectangle to represent the application itself, right? The web API application itself. Now, this application has to run all the time in order to wait for the caller's requests to come in. Right? So let's imagine that this web API application runs as a console application. So if you have learned C# before, you know what a console application is. So this web API console application has to run constantly and listen to network port in order to receive the user's request, right? The caller's request, and then process the request. So this is the application, right? This is the web API application. Now this application runs within the server and it listens to requests to come in from callers, right? So usually a caller would be a different application across the internet through the HTTP protocol. When this HTTP request comes into the server onto the network port, the web API then processes the request. Now the question is, how do we know which endpoint to hit? That is something that is called routing. All right, let's make this rectangle bigger. So one of the first steps of processing a HTTP request in the web API application is to route. So after routing, web API knows which endpoint to hit. For example, this web request may try to hit the create endpoint, right? Another one may try to hit the update, so on and so forth. Of course, there's so many different functionalities that a web API framework needs to implement in order to support developers to create web API endpoints and make a web API endpoint works for the callers. But like I said, routing is the minimum requirement for web API framework. So let's look at routing closely. Basically, routing maps a HTTP request to an endpoint. And inside the HTTP request, we have different types of information. We have the URI and we have the HTTP verbs. So HTTP has a post verb and it has a get verb. It also has a put or patch verb. Those are two different verbs, but it does similar things. That's why I put them together. Last but not least, it has the delete verb. So these verbs actually correspond to these CRUD operations. Post corresponds to the create operation. Get verb corresponds to the read operation. Put and patch corresponds to the update operation. And the delete verb corresponds to the delete operation. So the URI combined with the verbs would help us to do the routing. Like I said, there are so many different aspects or requirements that a web API framework needs to implement, but routing is the minimum requirement. That's why I covered a little bit in this video to help you understand how web API works. And then in the next video, we're going to do a demonstration to show you how web API works. In this video, I would like to demonstrate how Web API works with ASP.NET Core Minimal API. So this is Visual Studio 2022 and it's preview 3 for .NET 8. So instead of doing it with .NET 7, I decided to do it with .NET 8 because .NET 8 is going to come out by the end of this year, 2023. Let's go to File and try to create a project. You can search API. The first thing that comes up is ASP.NET Core Web API. So let's click on this. Let's call it Web API Demo. Click on Next, and over here, make sure this is unchecked, because if we check this, then we are going to use traditional controllers like MVC style Web API. Keeping this unchecked, we're going to use minimal APIs. And then we don't have to use the open API for the documentation. From the framework, I have installed .NET 8 preview version. Since .NET 8 is still under development, if there's any breaking change in the future, I'm going to come back and update my video. I'm going to click on the Create button. Now let's go to Solution Explorer. And you can see that we have a program.cs file. So this program.cs file, it's like a console application. When you run it, it actually runs as a console application. So let's actually give it a try. Right, without doing anything else, it already has some code in the template. Okay, so the application started. You can see that it has some logging here, right? The logging shows us that the application is listening to the localhost at the 7103 port. This is for the HTTPS protocol. And for HTTP protocol, it's listening to 5250 port, right? So this is what I mentioned in the previous lecture, where I said that the Web API application runs a console application, constantly listen to requests to come in. Okay, where does it listen to? It listens to a particular port. And I'm demonstrating that that's actually the case. It's listened to localhost, which is my computer itself, and then it's on 2 different ports due to 2 different protocols. So where is this port configured? You can go to Properties and go to Launch Settings. You can see that if it's HTTP protocol, it's listening to this 5250 port. Of course, you can change that, right? If it's HTTPS, it's listening to 5103 port. See, HTTPS 5103. That's this part of the diagram. And then we need to look closer at the routing, which, like I mentioned in the previous video, there are 2 parts. Right? One is the URI. The other one is the verbs. Let's look at them now. So we have some code already here. First of all, let's stop this. And then let's delete this class because we don't need it. Let's delete all of this. So you can see that here's the minimum code. We have this builder to build the application. And after building the application, we have the application, and then we say run. After we say app.run, the console application just runs constantly and listening to specific ports. This is just something that it tells the Web API application that if we receive a HTTP request, then it will redirect to HTTPS. In other words, it's always going to the safest port, which is the HTTPS port. Okay, let's look at the routing now, right? So let's look at how the routing works. First, let's imagine that we're creating an application for a company that sells shirt online. Then the API will enable the user to search for shirts, to add a shirt, to update a shirt, or to delete a shirt. Right? And for that, we'll need a URI like /shirts to get all of the shirts. Remember that we're also looking at the verbs. To read all of the shirts, we're using the get verb. So go back to this. So to read, so here actually, this is a read, right? To read, we're looking at the get verb. So we're going to say /shirts. So this is the URI part. This is the verb part. What it means that if there's a request that comes in with the URI, like /shirts, and the verb is get, then it's going to execute this function. Right? So we're going to use a arrow function. So this maps to this function that is hosted remotely. And what we're going to do is we're going to return rating all the shirts. Of course, we're returning this message just for demonstration purpose. In the real Web API endpoint, you're supposed to return all of the shirts in different formats, usually in JSON format, right? So you need to return a JSON array that contains all of the shirts. But right now we're returning the message just for demonstration purpose. And then now let's create another endpoint, which is going to map to the request where the user wants to see a particular shirt. And for that, we can allow the user to provide the ID, and then we're going to receive that ID right here in the arrow function. We use string interpolation. I'm going to say reading shirt, which shirt? This shirt, with ID like that. Okay, so this is going to tell us which shirt with which ID we're reading. And then we are going to create a shirt, right? And for that, we're going to map to the post verb. And the URI is the same as the get. And this is going to map to this arrow function, and we're just simply returning a message for now. Okay, creating a shirt. Of course, there has to be something posted into this function, which we're going to receive inside the parameter. But in this video, I'm not going to do that. I'm just demonstrating the minimum requirement of a Web API framework, which is to do the routing. Right? So that's the post, which is to create a shirt. And then we're going to update a shirt. For that, we're going to use the verb put. We're going to say /shirts/ID. We're updating a particular shirt. We're using this ID to tell the Web API which shirt we're updating. And again, we're receiving that ID right inside the arrow function as a parameter. And then we're going to say return. Again, we're going to use string interpolation in C#. We're going to say updating shirt with ID, this ID, right? And last but not least, we're going to do the delete. So for that, we're going to use the delete verb. And the second part of the puzzle is the URI, which we are going to tell which shirts we're going to delete. And that's the same URI, right? So this is the shirt we're deleting. And then in here, simply just return the message by saying deleting shirt with ID. Okay, we're done with the implementation of a very simple API. Doing this just to show you how API works, especially how the routing part works. Let's run the Web API application again. For the get endpoint, which is to read the shirts, we can use a browser, right? In fact, it actually launches a browser, which it points to the original URI. And this is configured again in the launch settings. You can see that it goes to the launch URI. So let's change this manually to shirts. So this is sending a HTTP GET, and you can see that reading all the shirts comes back. And if I say /1, and it says reading shirt with ID number 1. For reading the shirts, we are able to hit both of this endpoint with a browser. And to test the create and update and delete, we will have to use a tool. And the tool of our choice in this course is going to be the Postman. Right? It's a very popular tool, so which I'm going to use in this course. Here, I'm going to add a collection. And this collection, I'm going to call it Web API and .NET 8. And then over here, I'm going to add a request. So let's actually add the get first. Let's add all 4 endpoints. Let's save this, and then let's click on the send button. I think I got the URI wrong, so I'm going to click on send again. I got the response back. Right. So let's change this name to read all shirts, and let's add another one. And this is /shirts/ let's get the shirt number 9. Click on save. This is get a particular shirt. Right? So read a shirt. And then let's click on send. We can see that we're reading a shirt with ID number 9. So now let's try to do a post, which is to create a shirt. So let's copy the URI. So creating a shirt, we're hitting this endpoint with a post verb. And let's change to create a shirt. Save it and click on the send button. So it says creating a shirt. So we're hitting the endpoint, right, correctly. And then let's add another one. And this, we're updating a shirt with the same URI with ID. We're updating shirt number 10. And this verb has to be put. Click on send. We're hitting the endpoint. We're getting the message back. Now let's do our last one, which is the delete endpoint. And we're deleting a particular shirt with the delete verb, same URI as the update, or as the read a particular shirt, but different verb. Right, clicking on the save button and then the send button. Now we're getting the correct message. And this is a basic overview of how a web API works. And you can kind of foresee that your work as a developer is mainly inside here. You're going to implement all of the logic inside these arrow functions. Of course, it's not a good idea to put all of your code inside this one function. You may need to consider architecture, which I'm going to introduce later. Right? You may need to create different classes to handle different operations. But this is the basic. To sum up, let's go back to our diagram again. We have the web API application running as a console application, which you have seen here, right? It's constantly running and listening to specific ports. As soon as there is a request come in, the first job that it does is to do the routing, which is to map the request to a particular operation. And how does that work? It's using a combination of the URI and the verb to map to the endpoint. I have demonstrated here the URI and the verb map to this particular function, which is the remotely hosted function over the web. That's how we defined web API technically. Each one of these combinations map to a different function. I hope this demonstration have given you a basic understanding of how web API works. And I'll see you in the next video. ASP.NET Core provides a framework for developers to create web APIs. So in this video, let's talk about what is a web API framework. In the previous video, we have created a simple web API contains several endpoints. And I have mentioned as developer, our main purpose is to write logic and data operations within this function, right? The remotely hosted function. So let's go back to our diagram. So as developer, our main purpose is to implement these functions. So everything else needs to be taken care of by the framework. So what are those things? When I say everything else, what are those things? One of the first things I have covered in the previous video is the routing. We have seen that with the combination of the URI and the HTTP verbs, we're able to map a HTTP request to hit a particular endpoint. So that's one of the first things. In order to talk about what is a web API framework, we just need to cover all of the other things that a web API framework needs to provide to the developer. Right? The developer doesn't have to implement those by themselves. So we covered routing. Before routing, the user of the web API, which is another application, needs to be authenticated and authorized to be able to invoke the web API endpoint. Right? So that's what we call authentication and authorization. The authentication and authorization. And this happens before routing. And then the web API framework needs to be able to provide the information that is contained in the HTTP request into the function as parameters. And that is called model binding, which we have actually briefly seen it. So here, this is part of the URI. Now it becomes an integer. So who did the magic? That's the web API framework. Right? And this functionality of mapping the URI, or in the future you can see it's going to map from different places in the HTTP request to a parameter. This is a simple integer. In the future you may see a whole object mapped from the HTTP request to the parameter. So that's called model binding, and that's after routing. That's after we already know which endpoint to hit. And we have a functionality provided by the Web API framework, and that is called model binding. And after model binding, we need to make sure that the information that is provided as parameters to the remotely hosted function is correct, going back to the Web API. For example, the integer here, we need to validate it because sometimes the users could attack the endpoint for whatever reason. Right? We have to be prepared. And sometimes user can make mistakes intentionally. That's why we always need to validate the data that comes from the HTTP request. Anything that is sent by the user cannot be trusted. So that's why we have another functionality of the Web API framework, and that is called model validation. And after model validation, we are able to just hit the endpoint, right? And when it hits the endpoint, of course, as developers, our own business logic, data retrieval, data operations are executed. But what if there is an exception? Right? So the Web API framework also needs to be able to handle exception. So if there's any exception when we execute the remotely hosted function, then the exception needs to be handled. Right? So we can draw something like this. Exception handling. So after execute this, if there are exceptions, exception handling component will be able to take care of that. Last but not least, we should be able to return the data that the user requested in the format that the user requested. And that's what we call the result formatting. Okay, so what's going on here is that there's a request that comes in, and then it goes through the authentication authorization, routing, model binding. Now we have the parameter, and then we validate the parameter or parameters with the model validation, and then it runs the developer's own logic. If there's any exception, the framework handles the exception. And last but not least, the result of running the Web API is formatted by the Web API framework, and then the data is just returned back to the application. So the HTTP request goes into the Web API framework, and then the HTTP response, which is this line that is being highlighted, comes back to the user, which is the application. See, that's almost all of the functionalities that a Web API framework needs to cover. It doesn't have to be Microsoft's ASP.NET Core Web API framework. Any Web API framework will need to do similar things. I hope this is helpful for you to understand what a Web API framework is. And in the future, we will cover each and every single one of these components in the Web API framework. For you as a developer to understand how these things work is very important, so that you're able to focus your energy mainly on implementing the logic and data operations. Okay, I'll see you in the next video. In this video, we will explore how ASP.NET Core serves as a powerful Web API framework by utilizing a middleware pipeline. So in the previous video, when we talk about what is a Web API framework, I showed this diagram. And you can see that when an HTTP request comes in, it goes through several steps, and then it came out as a response. And once the user, which is the application that calls the Web API, requests for something else, another HTTP request is sent to the Web API, and then it goes through the same process, and then it comes out again as HTTP response. And this goes on and on. This reminds us of an assembly line. On an assembly line, we have different assemblers. Assembler 1, assembler 2, assembler 3, and the last one. There's many in the middle. Each assembler is responsible for a particular job. And of course, each responsibility is also different. So when a particular product goes onto this assembly line, then it goes through the first one, goes through the second one, goes through the third one, finally reaches the last one, and then the product is produced. This is very, very similar to what we just saw here This request is, you can consider it as some sort of message, right? And this message, similar to a product on a assembly line, goes through the first assembler, which is the process 1, right? Process 2, and process 3, until it reaches the last one, then it came back. Microsoft came up with a similar terminology. Microsoft called this a middleware pipeline, and each assembler is called a middleware component, right? So we have the first component, second component, third component, many components in between, and of course a message goes in, goes through these components, and each component does its own job to the message until it reaches the last one, and then this message is returned back to the caller. So again, this assembly line, now in Microsoft terminology, we call this middleware pipeline, and each one of these components is called a middleware component or simply middleware, right? And this corresponds to the assemblers. If we look at our code that we created previously for the Web API demo, you could see that there's this use statement, right? And this one is just use HTTP redirection, and there's others, like for example, use routing, use authentication, use authorization. All of these statements that start with use are for adding middleware components. This one adds the routing middleware component. This one adds the authentication middleware component. This one adds the authorization middleware component, and so on and so forth. Therefore, you can see that the architecture of ASP.NET Core is very simple. It's just a middleware pipeline, and it processes a HTTP request in the middleware pipeline, and the request comes in, goes through each one of these middleware components, and then finally reaches the endpoint. In the endpoint process, the request returns the information as a HTTP response. So that's how ASP.NET Core serves as a web API framework with a chain of middleware components. And this is very similar to the design pattern that is called the chain of responsibilities. That's what I want to cover in this video. I hope this helps you understand how simple and how powerful ASP.NET Core is as a web API framework. In .NET 8, there are two ways to create a web API. The first and simpler way is to use the minimum APIs. And the second way is to use controllers. In our demo, I have showed you the first approach, which is the minimal APIs. And you can see that it's very, very simple. There's only one file, which is a program.cs file. And you basically do all your work in this one file. Although this approach is very simple, very easy to understand, but it has its limitations. For example, we're dealing with shirts right now, and you can see all of the endpoints that are dealing with the shirts. What if we need to deal with other objects, for example, pants? Are we going to put all of those endpoints inside the same file? That is not very clean. So minimum APIs is only for simple scenarios. A better, cleaner, and more comprehensive way to create a web API is to use controllers. And when I say controllers, I'm actually referring to the MVC style controllers. We don't have to worry about what MVC is in this course, but we need to understand what is a controller. You can see the problem here. All of the endpoints are within the file. If we have controllers, then we can organize the methods in classes, right? Because a controller is basically just a class, which can be used to organize the endpoint methods. So let's actually start creating a controller. We can right click on the project and we can add a folder, and let's call it controllers. Now we have the controllers folder. We can add a class to it, and let's call it shirts controller. We have to make sure that this is called controller. There's some convention here. Now we have a POCO class, and if we want this controller to be a web API controller, there are two things we need to do. First of all, we need to derive this controller from controller base. And secondly, we need to use a C# attribute. Which attribute? The API controller, to decorate this class. So these two things makes the shirts controller a web API controller. Right? And inside here, we can basically create method for each one of these endpoints. For example, we can start creating the get shirts method to return all of the shirts. And we can just basically give the same type of message, rating all the shirts. And the second one would be get shirt by ID. And then here we're going to say rating shirt, which ID. We can use string interpolation. And then here we'll have our create shirt. And the message is creating a shirt. And we're going to have our update shirt, which takes a parameter. The message would be updating shirt. Last but not least, we have our delete shirt method, and message is going to be deleting shirt. So now we have our controller, and you can see that this approach of grouping the CRUD operation methods inside a controller is a pretty good architecture. So if we were to create a set of endpoints for pens, then we can just come over here, create another controller, and we can call it pens controller. We can do the same thing. I'm not going to actually do it, but as you can see, using controllers is a much cleaner way to create Web API endpoints. And because of that, we have much better maintainability in our code base. So now the question is, given a HTTP request, how do we map that HTTP request to a particular method inside the controller? I'm going to talk about that in the next video. To sum up, a controller is basically just a class, and there are two things you need to do to make it a Web API controller. One is you have to derive from the controller base class. Secondly, we need to use the API controller attribute to decorate the controller class. So as long as you have these two things for the controller, and then you call this class something controller, then your class is a Web API controller class, which can be used to specify the endpoints for your Web API. In the next lesson, I'm going to talk about how to map a HTTP request to a particular endpoint inside a controller for a controller-based Web API. I'll see you in the next one. In the previous video, we talked about when we inherit our controller from the controller base class, and when we decorate our controller class with API controller attribute, this makes the controller a Web API controller. In this video, we're going to try to understand routing in controller-based Web API. Basically, how to map a HTTP request to each one of these methods. And by the way, these methods in the controller is called action methods. So the question is, how do we map a HTTP request to these action methods? Let's go to the program.cs and observe what we did for the minimal APIs. What we did was we used the map methods, and also we specify the URL. We also, of course, specify the verbs. For controllers, it is very, very similar, but instead of using these map plus verb functions, we use map controllers. So let's delete this. Later, we're going to talk more about minimal APIs, but for now, let's focus on controller-based Web API. So instead of using map get, map put, map delete, map post, we're going to use app.mapControllers. Okay. So this will help us to map the HTTP request to controllers. Right? And the second thing in the minimum API is that we specify the URL. So where do we specify the URL in controllers? Let's actually go to the controller class. And here we can use the attribute. And this is called attribute routing. We can say that we're routing to this URL, shirts, and we're mapping this shirts to this particular action method. And of course, the third thing we also need to specify is the verb. This is a HTTP GET. So we covered three things that minimal API covered. First of all, we used map controllers. So this map the HTTP request to our controllers. Secondly, we specify the URL just above the method, right? So that the Web API framework knows that we're going to map this URL to this action method. And then we specify the verb. Right? All those things that we did in the minimal API, we're doing them here just above the method. And then the same thing here for the get shirts by ID, this is also a HTTP GET, but just different bots. So here, we're going to just specify the ID just like in minimal API. And create shirt, we're going to say HTTP post, but the same routes. What about update? We are going to say HTTP put, just like in the minimal API. And of course, the route is the same as the get shirt by ID. We need to specify which shirt we're updating. And here is the same thing, same route, but different verb. So here for delete shirt, we're using delete. So we covered all of the endpoints, but there's just one thing we also need to cover. We go back to the program.cs. Now we're saying we're mapping controllers here, right? But mapping controllers is way complicated than mapping to the functions inside minimum API endpoints. Here, the map controllers have some dependent services. Without those dependencies, the map controllers will not work. So where do we register those dependencies? Into our Web API framework. In the Visual Studio Web API project template, we can see the comments here, add services to container. So we can just do that. We're going to say builder.services, and we're going to say add controllers. We don't have to add the dependencies one by one manually. Add controllers is a extension method, right? C# extension method that is already provided by ASP.NET Core. Basically, add controllers registers those dependent services in the container for map controllers to use. And then whenever the mapping controllers require those dependent services, ASP.NET Core will create the instances or directly take the instance from the container and then provide those instances to the mapping mechanism. So with all of these changes, pretty simple changes, we are able to make the API work now. So let's actually give it a try. Let's run the web API and let's bring up our Postman. Let's try each endpoint one by one. Let's click on the send, and then we're saying rating all shirts. Let's read a shirt, rating shirt number 9. Let's create a shirt. We're not actually creating, we're just talking about routing here, right? And then update shirt, updating shirt number 10 and deleting shirt number 11. So all of the endpoints are working in terms of routing. So that's actually the first way to route, right? Basically mapping HTTP requests to action methods in controllers. Another way to do it is to, instead of using the route on each one of these action methods, you can put the route attribute on top of the controller class. And then we can provide a routing template here. You're going to say controller, and this is a route template. This is a placeholder for the name of the controller. In this case, it represents shirts. Therefore, we don't have to use the route attribute on each one of them and write /shirts for all of these endpoints. We can actually delete this one, and then we can delete this one. But when we delete this one, where does the ID goes? And the ID can go into the HTTP GET here. So we can say ID just like this. Same thing here. This one can be deleted because there are no parameters need to be specified. And this one is similar to HTTP GET. We're going to specify the ID over here. Now this one is very similar. We're going to delete this and we're going to put the parameter inside here. Okay, now let's try to test this way of doing routing in controller-based web API. Before that, let's add a base URL here. Let's say API/. So this all of a sudden will change all of the endpoints URL, like the base URL, to /API/shirts. Right, so let's run it again. And then let's go over here. Now, if I do send a request, it's going to say 404 because the endpoint completely changed. Right? That's why the original endpoint is not found. So in order to make it work, we have to say API/shirts. Right, let me copy this and then click on the save buttons. Let's say save and overwrite. And then If I click on send, now I can see it, right? For the rating one, I'm going to get the same thing for 4, unless I change that to API/shirt and click on sending. I'm rating shirt, right? So let's do the same change for all of them. So I'm creating shirt, right? And for update, if I just run it, I'm going to get the 404 not found. Paste, change that to API/shirts. Now I get my result. Last but not least, we're testing the delete endpoint. Again, we're getting 404. Now we use API/shirts. Now I get deleting shirt number 11. So now you can see that we can use a route template on top of the class instead of here. And then the parameters can be just provided through these verb attributes. So those are the 2 ways you can configure routing controller-based web API. The first way is to use route on each one of these action methods. And the second way is to provide a route template on top of the controller and then provide the parameters through the verbs. Okay, that's everything I want to cover in this video, and I'll see you in the next one. In this video, we're going to talk about model binding in ASP.NET Core Web API. So what is model binding? Model binding is the process of mapping data from HTTP request to the parameters of an action method. In this particular action method, you can see an example. The ID is mapped from the route of the HTTP request into the integer parameter of the get shirt by ID action method. So since model binding is mapping data from HTTP request to our action method parameters, then we have to know where the data is actually stored in the HTTP request. Let's look at this picture. And this is basically the anatomy of a HTTP request. We have a HTTP request like this, and this is the verb, right? The HTTP method. This part is the path, or we can call it the route. And after the route, we have query strings, which is not shown in this example. But the query strings are those start with question mark, and then the query parameter, followed by the query value. And after that, we have this bracket. All of this data are HTTP headers. And you can basically see that HTTP header has a key value pair, right? The key and the value, and then another header key, another header value, right? So on and so forth. So after the HTTP header, you can see the HTTP body here. And it's also sometimes called the payload. Usually a HTTP GET method wouldn't have a body, right? Even you have a body, it's mainly ignored. A body makes sense for a post verb or a put verb or a patch verb. It doesn't make sense for a delete or a get verb. So this is the anatomy of the HTTP request. So where the data can come from? The data can come from all those different places that we just talked about, except the verb. Let's have some examples of those different places. We already have an example of the route. The ID is mapped from the route to our ID parameter here. Let's say that in addition to the ID, we also need to receive the color of the shirt. Right? And let's say that the color is a string variable here. We can receive this from the route. So how do we do that? We can do slash, and then we can put color here. So then this will be mapped to the parameter. And then of course, we want to display the color. Okay, let's give it a try. We're bringing up our postman, and here, followed by the ID, we can put the color of the shirt, which is red in this case. And then let's click on the send button. And you can see the response comes back and displays the color red. This example shows that data can be mapped from the route to the parameter of the action method. In addition to let ASP.NET Core to decide where the data comes from, you can actually specify where the data come from. In the previous example here, when we have color, it'll automatically map to here from the route because this is the only place the color is provided, right? But you can actually specify that the data has to come from the route. So in this case, you can say from route. Then if the data come from somewhere else, it's going to throw an exception, right? Basically saying that you're missing the color parameter here. So where else it can come from? It can come from query string. So let's remove this. Now let's test this. If we send this request without providing the query string, you can see that the color field is required. That is basically a 400 byte request. But what we can do is to attach a query string, and we're going to say $color equals, let's say blue this time. Now let's click on the send button. You can see a HTTP 200 returned, and we're receiving the correct message. Now we have demonstrated from route, from query. I can also demonstrate that the data can come from the header. So in this case, I'm going to specify the color is going to come from the header. Remember that header has a key value pair, so we can specify what the key is. In this case, the name. Right, so I can say that the key is color. I'm going to run this, come over here, go to the header. We can add the header here, and the key is color. And here we're going to say purple. And let's click on the send button. Now we are receiving the correct message. The color purple comes back. So this example demonstrates that the data can also come from the header. And in order to do that, we can specify the name of the key. Okay, so I have showed the data come from the route, from the query string, from the header, and those places, usually we're binding primitive type of data. That means like a number, a string, so those kind of things. So now we comes to model binding from the body. Let's delete this, recover to the previous state. Now, when we provide data through the HTTP request body, we're usually using the post or the put. So let's using the post as example. We're posting data through the body. When we do that, we're usually posting complex type of data. And to demonstrate that, I'm going to create a class. And first of all, I'm going to go over here to the project, and then I'm going to create a new folder. I'm going to call it models. And under the model, I'm going to create a class. And I'm going to call it shirt. And of course, a shirt will have a shirt ID. It will have a brand name. Here, I'm allowing the brand name to be null, so I use question mark. And it's also going to have a color property, a size property, and a gender property, allowing it to be null. For color, I'm allowing it to be null, so I'm using question mark all over the places. And last but not least, I'm going to have a price property here to store the price of the shirt. Now let's use the create shirt action method as example. When the create shirt action method is triggered, we want to receive the shirt that we want to create. And then we can specifically say that the shirt should come from the body. And let's give it a try. Let's actually set a breakpoint here, and then let's run debug. And let's go to our create shirt method. Currently, we don't have anything in the body. So let's click on raw and let's select JSON. We can come up with a shirt. So let's say the shirt ID is 1 and the brand name is, let's just say my brand. And if I click on the send button, now my breakpoint is triggered. If I hover over the shirt parameter here, I can see that I actually received the data. Shirt ID is 1. My brand name is my brand, and everything else is the initial value. So now you can see that we are able to post complex type of data through the body. Another place where we can post complex type of data is from the form. And let's run it, and let's try to post data through the form. And let's run debug, and let's delete the JSON here. And instead of selecting raw, let's using the form data. And you can see that form data also comes with key and value pair. So what do we do here? We can just provide the different properties. So first of all, shirt ID, I'm going to do number 2. And the brand name, I'm going to say your brand. And let's say the color is yellow and the size is, let's say 12, and the price is, let's say $30. So with this data in the form, let's click on the send button. And now you can see that the breakpoint is triggered. Let's hover our mouse over the shirt parameter here. You can see that we received all of the data here. Okay, so this is from form. And actually the form is within the body part of the HTTP request. Let's sum up. I've showed you what is model binding, right? Which is to map data from the request to the parameters. And then there are different places in the request. Their route, their query, their headers, their body, and their form. I've demonstrated all of different places. Of course, there are other places that you can reference, but usually we don't put data in there, so I'm not demonstrating that. Hopefully, after this video, you know exactly what model binding is, and you know where to put data and how to use these attributes to specify where the data come from. Okay. I'll see you in the next one. In this video, let's talk about model validation. In the previous video, I have covered model binding. So model binding happens before the action method is triggered and is responsible to provide the data as a parameter to the action method. But what if there's something wrong inside the data, right? Who's going to validate that? As a developer, we definitely can do that manually inside the action method. We can examine the parameter value and make sure that everything is valid. There's nothing wrong with the data and there's no chances to break our application. Yes, we can do that manually, but ASP.NET Core Web API framework provides that functionality for us already, and that's called model validation. Model validation is triggered in between of these two steps. And if there's anything wrong, it's going to spit out a nicely formatted message to the caller. There are a couple ways to take advantage of model validation that is provided by the ASP.NET Core Web API framework. One way is to use data annotation, and that's what we are going to cover in this video. To use data annotation, we should go to the definition of the parameter type, which is the shirt class in this case. Let's go to the definition, and we see a bunch of properties. And we need to annotate on these properties to specify certain business rules. For example, if we require brand name always to be there, then we can say required. And you can see that once I tap, the namespace will automatically be imported. This namespace appear here. Let's say that color is always required, but size is not always required. So in that case, instead of using integer, I'm going to use integer question mark to specify that the size is nullable. Let's say gender is also required, so I'm going to use required as well here. And price is not always required, so let's use a question mark as well. So this is a very simple annotation coming from the data annotation namespace. And this namespace has nothing to do with Web API. So you don't need to worry about introducing any extra stuff that is related to the Web API framework into our POCO class, plain old C# object. So basically I'm saying that these attributes are not changing the nature of the class, so you can feel free to use it. Once we putting annotations on the properties of the class and use that class inside the action methods, ASP.NET Core Web API will automatically use those annotations during the step of model validation. So whether you do anything with the shirt class or not, model validation will always happen there. It's just that when you have those annotations on the properties of the incoming class object, model validation will know how to validate those properties of the object. So let's give it a try. Let's run the Web API and let's bring up our Postman. So instead of using form data, let's switch back to raw and using JSON. First of all, our shirt ID, let's say 1. And if we don't provide anything else, and let's just send this to the endpoint and see what's going to happen. So I'm clicking on the send button. Now you can see that we have an error message, and it tells us that the brand field is required, the color field is required, and the gender field is also required. The HTTP code that is returned is 400, which means it's a bad request. So who actually spit up the error message? It's the model validation of the ASP.NET Core Web API framework that actually happened before the method is triggered. Because you know that if the method has already been triggered, then we know that we are going to get this particular message. But instead of getting the particular message, what we got is this message that comes back as a JSON. And it tells us exactly which field is wrong. So because of this, you know that model validation actually happened after model binding and before the action method is invoked. So let's actually make this endpoint work by specifying the brand. And I'm just going to say my brand again. And then color, I'm going to say red. And gender, I'm going to say male. So with all these required properties provided, if I click on send, I'm expecting this is going to pass and we're going to get HTTP 200 as the response. And I'm clicking on the send button now, 200 OK is back. And we're seeing the message creating a shirt. So just to sum up, in order to take advantage of the model validation that is provided by the framework, one of the first ways that we can use is to use data annotation. And for that, we can just use data annotation attributes to decorate the properties that we want to validate. And in this video, of course, I only use the required attribute, but there are so many other attributes we can take advantage of. Let's take a look at the other attributes in the documentation from Microsoft. So you can see that under the data annotations namespace, we have so many different classes. We use the required attribute here, but you can use other attributes. For example, you can use a range attribute to specify that a particular number has to be inside a range, right? And a phone attribute to specify that the data field value should be well-formed phone number. And a URL attribute provides a URL validation to make sure the provided string is in a URL format. And a compare attribute to compare two different properties. You see that there's so many different things you can do with the data annotation attributes under the data annotations namespace. So that's the first way you can take advantage of this model validation step inside the Web API framework. Okay, I'll see you in the next one. In the previous video, we talked about model validation by using data annotations. And these annotations are just attributes that are used on a single property of a model class. But what if there are more complicated logics that require us to look at multiple properties at the same time? In that case, we can create our own attributes, and that's called validation attribute. So in this video, we're going to cover creating our own validation attributes. So the scenario that we're going to use is this. For men's shirts, the size has to be greater than 8. Anything that is lower than 8 is not valid. For a women's shirt, the size has to be greater than 6. Anything that is lower than 6 is considered invalid. Right? So there's some kind of logic there that we have to use 2 or more different properties, combining them together to determine whether the input is valid or not. So this kind of validation will has to be done with custom validation attributes. Okay, so let's go ahead and create that. Let's go to our solution, and we have this models folder. Typically, you're going to have multiple model classes under the model folder. For validations, one way we can do it to organize these classes properly is to create a subfolder, and we're going to call this folder validations, and we're going to create validation attributes under this validations folder. So let's go ahead and create a new class, and I personally want to start the validation class with the name of the model class. so that I know that I'm validating a shirt. And what I want to do is to ensure the correct sizing. So ensure correct sizing, and I want to call it attribute. Okay, so what we want to do is we want to create an attribute so that I can use this attribute to decorate the size property like this. So what should I do to make sure this is an attribute? Of course, I have to derive from an attribute class. And in this case, it's not just any attribute class. It's called the validation attribute right here. And then what I need to do is to override the isValid method. I'm going to choose the second one that has the validation context. Okay, let's go back to the shirt and let's do a control dot to import a namespace. I can see that this one is a valid attribute. In fact, I can remove the attribute and it's still working. So let's go back to our validation attribute. What we need to do is we need to get the model object from the validation context. So I'm going to say shirt, and I'm going to say validation context dot object instance as a shirt. Why we're sure that this is a shirt? Because we are using this to decorate one of the properties of a shirt object. So that's why we are sure that this is going to be a shirt. And therefore, we can get the object instance directly from the validation context. So now I have a shirt object. I'm going to say if shirt is not now, then I'm going to implement the logic here. So the logic is if shirt dot gender equals to men. So I'm going to say ordinal ignore case. So if it's equals to men, then I have to make sure the size is greater or equal to 8. So shirt dot size. So if it's smaller than 8, then I'm going to return the error message. Okay, so I'm going to say return new validation result. And this error message is the size has to be greater or equal to 8. Let's make it clear. Let's say for men's shirts, the size has to be greater or equal to 8. And here, I'm just going to validate women's shirt. Let me copy this. And I'm going to change to 6 and change this one to women. Then I'm going to change this message to 6 and this one to women. And of course, here you can see that it's warning us that this can be null. I'm going to say that if the shirt.gender is not null or empty, then I'm going to do the comparison. Right? Otherwise, this is going to be just a success. Validation result dot success. So after we complete the validation attribute, we can just take the attribute name and put it onto the most appropriate property. In this case, we're validating sizing. So therefore, we're going to put this one here. Okay, I'm missing a if here. It's if. And now we can try this web API application. Let's run this and let's bring our Postman here. In this case that we tested in the previous video, so before we can test, we need to change this male to men. And then we can test sizing. So size, we say 3. I'm going to expect that it's going to say there's something wrong because the size is incorrect. Okay, it's telling me that for men's shirts, the size has to be greater or equal to 8. So let's use 7. Okay, testing edge case. Then it's going to be testing, we're going to test 8. Now it's correct, right? And then let's test another case. Let's say 80. That's a very big one. We should actually implement something to make sure that it's not going to be too big, right? But in this video, let's skip that. So it says 10 should be good. That's a normal case. All right, so let's change that to women. For women, number 6 should be good because it has to be greater than 6, greater or equal to 6. So that's fine. But number 5 is not good. You can see that it's telling us it has to be greater or equal to 6. And number 7 is a normal test case. Okay, and let's test another one. Let's say number 12. This means that our validation attribute is actually working. And this video shows you how we can actually create our own validation attributes instead of solely relying on the data annotations. Okay, I hope this helps, and I'll see you in the next one. In this video, I want to talk about return types of these API endpoints. You can see that currently we're returning string for every endpoint or every action method. Of course, actual endpoints will return actual data. For example, the scat shirt by ID will have to return a shirt. But should we just return a shirt, or should we use a different return type? In order to find out, let's actually define a list of shirts first. So I have something in my clipboard. I'm just going to paste it here. You can see that I have a list of shirts. There are 4 of them from ID 1 to ID 4. So currently everything is in memory. Eventually we're going to use repository pattern. We're going to retrieve the data from database. But for now, while we're learning everything about Web API, we're using a in-memory list. To implement this endpoint, we just need to get the shirt from this list. Okay, so let's delete this, try to implement the endpoint with this in-memory list. So we can use link. So we can do shirt ID equals ID, and then we can return this. Okay, and we need to change this return type to shirt. And let's watch what's going to happen. Let's run the application, and let's bring Postman here. I have ID number 9. Of course, it doesn't exist. So let's change something that exists first. Number 2, I click on send. I get a shirt in JSON format, which is excellent. Right, so what if I enter something like I just did? It's number 9. What do I get? Now you can see that I have a HTTP 500 internal server error. So for anything that is unhandled, this is a generic error. And then you see this stack, and it's not very user-friendly, although it's very good for troubleshooting, right? But for end user, which is an application that calls our web API, it shouldn't actually see this. What do we have to do here? We can use link, use first or default to actually look for the shirt first. And then if the shirt is null, then we need to actually return a HTTP 404 not found. So we actually have a convenience method. This is called a convenience method. And you can see that this convenience method actually creates a not found result that produces a 404 not found status code, right? HTTP status code. But if we do this, you can see that it complains that this return type doesn't correspond to the return type of this action method. If we actually found a shirt, we should return the shirt. Ideally, we should specify the status code at the same time. And we have another convenience method in ASP.NET Core, which is OK. You can see that this OK creates a OK result object that produces an empty status code 200 OK. And we can put a shirt in it. So this way it returns a shirt as well as a HTTP 200 status code. So that means this return type cannot be shirt. In an action method that returns multiple types, we should use the iActionResult interface. This is an interface that you should use when your action method returns different types of data. In this case, you can see the compiler stops complaining, and we can give it a try. Okay, so with the same ID, number 9, which doesn't exist, I click on send again. Now I can see a better error message. We can see the status code is 404 not found, and it's also showing here, title is not found. So this is a user-friendly error message. What if I put something that exists? I still get the JSON object back. So that's a correct way to do it. So instead of using shirt, the actual class, we can use the iActionResult. And another scenario is, what if user enters a ID that is less than 1, less or equal to 0? Then we should return a different status code. So in this case, we're gonna say bad request. This is another convenience method that creates a bad request result that produces this status 400 bad request. And in this case, if we test again, you can see that if we put -1, we get status 400 bad request, and we put 0, we also get bad request. We put 4, we return a correct shirt back, and we put 5, HTTP 404 not found. So you can see that everything is correct. So that's what I want to cover in this video. Typically in ASP.NET Core, you want to use iActionResult as the return type, which will make everything simple and consistent. Basically, you can put iActionResult in every single case. And then, of course, here, if you want to return just a string, you can just use OK. And same thing with this. Okay, now I've changed everything to return iActionResult. So when we use ActionResult, it simplifies the development process. Everything is consistent. And we are doing unit testing. iActionResult is consistent, so our unit tests can be easier. It doesn't have to target different return types. So there's so many different benefits of using iActionResult as the return type. And that's what I want to cover in this video. I'll see you in the next one. In the previous video, we have been using this in-memory list within the controller. Like I said before, eventually we're going to use repository to retrieve data directly from database, but we still don't want to have a in-memory list within the controller. We would rather have an in-memory repository that hosts the in-memory data in there. So in this video, let's go ahead and do that. Let's go to our Solution Explorer, and let's go ahead and create a repository folder under the models folder. Because this is a in-memory repository, that's why I'm creating it under the models folder. Eventually, when we work on actual repositories, we're going to create a class library for that purpose. Repositories, and let's create a class, and let's call it shirt repository. This is going to be, like I said, an in-memory class that hosts the data, and that's why I'm using a static class. And let's go to the shirt controller, and let's cut this and paste it over here. So of course this will become a static member that hosts the data inside the static class. And we will need two methods here at least. Right. The first one is that we need to be able to tell whether a shirt actually exists in the in-memory data store or not. Okay, so shirt exists, and provide ID here. And we're gonna simply just use link. We're gonna say x goes to x dot shirt ID equals ID. Right? If there's any of them, then it's going to return true. So the second method we're gonna implement is get shirt by ID, and we're going to return shirt, get shirt by ID. So now again, we're gonna use link. We're gonna just say first or default x goes to x dot shirt ID equals ID. Now it gives me this green squiggly line. It's telling me that possible null reference. Well, because I'm using .NET 8, I think I mentioned before, I have to use question mark just to specify that I accept the possibility of having a null as the shirt. Right? And then we're just going to handle that in our code. All right, so after I implement this, I am going back to the shirt controller, and I'm going to use the repository. So here, everything's fine, but here, I don't have shirts anymore. I'm just going to use shirts repository, and I'm going to get shirt by ID. I provide the ID over here. So if it's null, then not found. Okay, let's give it a try and see whether it works or not. Okay, using our postman, we're going to get the shirt on number 3. We're still having the shirt. Right? What if I provide -9 and I have a bad request 400, that's correct. But if I have +9, I have a not found 404. So that's all correct. And that's what I want to cover in this video. And I'll see you in the next one. In the previous video, we have used shared repository, replaced in-memory list in the controller. In this video, we want to deal with these validations. As I mentioned before, the main purpose of having this action method is to provide the endpoint and share the data in this case. So the main purpose is to deal with those logic that shares the data, deal with those coding that share the data with the outside world. So these validations, you can do it inside the action method, but that's not completely following the single responsibility principle. Previously, we have used validation attributes to validate it. The problem with validation attribute here is that it doesn't specify what type of status code. Here we're specifying BAT request, that's HTTP status code 400, and here we're specifying not found, that's HTTP status code 404. So is there a place where we can extract these validations and put it in that place and still allow us to return these HTTP code back to the caller? Yes, and that's something that is called ActionFilter. So ActionFilter is basically just the extension of the middleware pipeline. If we look at filters in the ASP.NET Core, and I'm looking at ASP.NET Core 8.0 preview, you can see that this documentation specifies this. And this gray box is where the filter pipeline goes. And it's basically just an extension of the middleware. So we have this MVC action, which is a middleware by itself. So inside this MVC action middleware, we extend the other middlewares outside of the MVC action and provide mini middlewares. And we call those mini middleware filters. And if we scroll down, you can see how that goes. So this box is basically just this gray box, and this request goes in and response goes out. So these ones, you can just consider them as mini middlewares, but Microsoft give it a different name. We call it filter. And there are different filters. In this video, I want to cover the action filter. You can see that action filter is triggered before the action method is invoked, and is also triggered after the action method. And in this video, let's use action filter to do data validation. And therefore, we're going to extract this into an action filter. Let's create a folder, and let's call it filters. And inside here, let's add a class. And let's look at this. We're trying to validate the shared ID, right? So let's provide some meaningful class name here. We're going to call it shared underscore validate shared ID filter attribute. And this is going to derive from ActionFilter attribute. And when we derive from that class, we can override a couple of methods. You can see that we have this onActionExecuting, which is triggered before the action method is executed. And then we have the onActionExecuted, which is triggered after the action method is triggered. So we're going to use the onActionExecuting because we want to validate the data. We don't want the data to come into the action method if it's invalid. And here, first of all, we want to get the shared ID in order to validate it. So we're going to say var shared ID. And where do we get it? We get it from the context. And there is an action arguments. So this directly targets the parameter now. And we can just specify the name of the parameter. Okay, let's go back to the controller just to be sure what we're talking about. We're referring to this parameter of this action method. So eventually that filter attribute is going to be put onto this method, right? It's going to decorate this method. So we know that this is the parameter that comes into that argument array. That's why we're using ID here. And then we're going to convert that to an integer. But you cannot convert it to just an integer. We do it this way. You can see that it's going to say action arguments is not now here, right? It's dealing with those nullable thing. So we just need to specify this is a nullable integer. Okay. And if the shared ID has value, that's what we want to validate, right? When the shared ID has a value, we want to validate it. If it doesn't have value, it's a different story. We don't want to do with that in this action filter. So first of all, we can say shared ID dot value. If it's less or equal to 0, what is going to happen here is that we are going to add an error to the model state. And we're going to say shared ID, that's the key, right? So basically, which field has the problem? Well, in this case, we're not dealing with an object, but we're dealing with this parameter, shared ID parameter. So shared ID is having a problem. I'm going to say shared ID is invalid. And then we're going to say context.result equals new bad request. See here, we can specify what type of HTTP response. So here, we just need to specify the model state here. So the next validation is to see whether the ID exists or not. And for that, we can use the shared repository and we can say shared exists. So you may have been wondering why we created this method in the previous video. That's because we're going to use it here. Okay, so I'm going to say shared ID dot value. So if this doesn't exist, so that's a problem. And we want to short circuit the pipeline by doing this. So copy and paste that over here. And here the error message is different. I'm going to say shared doesn't exist. And the response type is different. This is not found object result. Okay, going back to the shared controller, we don't need this anymore because we are going to use the action filter to decorate this. And let's go to the action filter, just copy this part and put it over here. All we need to do is just to do shared repository, and we're going to get the shared by ID. We don't need any validation because we know that the filter is going to be triggered before this action method is invoked. Okay, let's give it a try. Okay, so let's test some proper test case. Number two exists. Let's say number three also exists. Beautiful. What about -1? We get this error message and it says shared is invalid. And what about number 19? And we have another error message and it basically says shared doesn't exist. Okay, and that's what we want to see. That's exactly what we want to see. However, there is a problem. You can see that this error message is inconsistent with the error message that we got from, let's say the create shared. We got this type of error message. So this is from the validation attribute. And it's actually, when we have a minus value, you can see this error message is also different from what we got in the validation attribute validation. So how do we fix that problem? It's very easy. Let's go to the shared validation attribute here, right? This filter attribute here. And instead of passing the context model state here, we can create a problem detail object here. So problem details equals new validation problem details. And here we just need to provide the state, right? Instead of providing the state directly to the request, the bad request object result, we provide it over here. And also we can specify that the status is status code 400. So 400 bad request. And then instead of providing the model state, we can just provide problem details object as the input parameter. Okay, and we're going to do the same thing for the existence checking. We put it over here. We use the model state inside. We just need to change this to 404 not found. Okay, and we're going to again use the problem details instead of the model state. So let's give that a try. All right, so we are looking at get assured. The parameter is -8. So now we're having very similar format of the error message, right? Comparing with this one, it has title status errors, and this one also has title status errors. And what if I put 88? So this one doesn't exist, shirt doesn't exist, and we have a 404 not found status code. So in this video, you have seen how we can use a action filter to do the validation. Like I said just now, when we use the filter attribute to do validation, we can return different results, and that's what we like. Okay, so that's everything I want to cover in this video. I'm going to see you in the next one. Starting from this section, we're going to work on implementing these endpoints. And in this video, let's start with the get shirts. So currently, we're returning just a message. Actually, we will need to return all of the shirts. And for that, let's work on this shirt repository. I know this shirt repository currently is a in-memory representation of the data store, but that's for the ease of learning. So let's use the in-memory representation of the data store for now, and then later we're going to introduce .NET Framework Core. So for getting all of the shirts, we can just create a static method here. It's going to return us all of the shirt. I'm going to call it get shirts with no parameters, and we can just simply return the shirts like this. And go back to the shirts controller over here, and here all we need to do is to just call the shirt repository and get the shirts. Okay, so let's bring up our Postman and let's test this. Get shirts endpoints. Clicking on the send button, and we're getting all of the shirts. Currently there are 4, we're getting all of them. All right, that's quick and easy, and I'll see you in the next video. In this video, let's work on the create shirt endpoint, since we have already implemented this get shirt by ID endpoint. Okay, so currently we are returning a message, and in order to replace this with actual creating the shirt, we'll need to work on the shirt repository to add a shirt into the list. So again, we're going to create a static method, and this add shirt method is going to return nothing, right? So it's void. And then add shirt will be the method name. We're going to pass in the shirt object that we want to add to the data store, right? Which is the in-memory list. And of course, we can simply do this, but there's just one problem with this, because the object does not contain a shirt ID, because we don't know what the ID is until we add it to the data store. But because this is not a database, so we'll have to manually generate the ID. So what we are going to do is we're going to say max ID, and then we're going to use link to get the maximum ID from the list. So we can just say max, and x goes to x dot shirt ID, and this will give us the maximum ID. And then we're going to assign a new ID to the shirt, and it's going to be just max ID plus 1. So now that we implemented this method, let's go back to our controller and let's work on implementing this. So we'll need to do some validation, and you can see that Visual Studio already anticipated that we need to check whether shirt is null or not. So we're going to just say this. If it's null, then we're going to return a bad request. We're going to do this for now, and then later we're going to work together to create a action filter. Okay, that's the simple validation that we have just implemented. But let's actually go to the models and look at the properties of the shirt. Do we allow 2 different shirts to have the same values for these 4 different properties? No, we cannot allow that because that doesn't make sense. So we need to do a validation for that as well. So let's go back to our controller and work on that validation. What we need to do here is to check whether a shirt already exists by providing the brand, the color, the gender, and the size. For that, we will actually need to add a method to the shirt repository. So let's go to shirt repository and let's add another get method here. So we're going to say static, and we're going to return a shirt. I'm going to say get shirt by properties. Let's just name it like this. So we're going to compare the brand, and we are going to compare the gender, and also the color, and also the size. Why I'm using question mark all over the places? That's because when we go to the shirt, you can see that we're using question mark over here. So that's why we're also using question mark to make sure we're doing it consistently. Okay, so the task here is to find a matching shirt based on these properties. And to do that, in our in-memory repository, we can simply just use shirts.first or default. It's a link method. And first of all, we need to make sure that the brand is not now. So it's now white space brand. Also, we need to make sure the brand for the x.brand is not now or white space. Now we do the comparison. I'm going to say x.brand equals brand string comparison dot ordinal ignore case. So that's how we compare the brand. And we're going to do the same thing for gender. So and then we're going to change all of these to gender. So gender, this one is gender, this one is gender, and we're comparing gender with gender. Okay. Now I'm going to do the same thing for color. So this one is color. This one is also color, color, and color. Okay. Now we are actually going to do the same thing for size, but for size it's a little bit different. So let's start typing this. So we need to make sure that the size that is passed in has value, and we also need to make sure that the size of the element also has value. And also we want to make sure that size.value equals to x.size.value. Okay, so when all of these satisfies, we return a matching shirt. Okay, so now let's go back to our controller and let's try to find a existing shirt. Right? Find out whether the shirt exists or not. And we're going to use the newly created method in the repository, and that's get shirt by properties, and we just need to provide the properties. Okay, this is brand and shirt.gender, shirt.color, now last but not least shirt.size. Okay, so if this one is not now, that means we already have a matching shirt. That means it's a bad request. We can provide a error message later when we implement the validation with ActionFilter. For now, let's just say bad request. Okay, so now we have all of the validations, and what we need to do is just to add a shirt into the repository. So add shirt and then shirt. And now instead of using the convenience method for returning HTTP status code 200, we need to use the convenience method to return HTTP created. I think that's 201. We need to say return created at action. And you can see that this one produces a status code status 201 created. Okay. And the first parameter is the name of the action, and we can say name of get shirt by ID. Okay. And then the second parameter is, let's use the raw values. Okay. We can use dynamic object for the raw parameter here. And that's the shirt ID. Because once we add this shirt object to the repository, we have a shirt ID. Right? And this shirt ID, along with the name of the action method, will return as a location header, which you're gonna see once we start testing. Last but not least, we need to provide the shirt object over here. So this is a convention of Web API when we are working on a create endpoint. We should return a created status code with a location header and the object itself as a JSON. Okay, we can test the endpoint now. Let's run the Web API and let's actually run this read all shirts for now. And you can see that we only have 1, 2, 3, and 4. So let's copy this last one and let's go to create shirt and let's paste it over here. Let's delete the shirt ID. We don't need it. But if I don't change anything here, I'm expecting it to return me an error because these properties all exist, these 4 properties, right? So let's click on send and we can see that this is a bad request, right? Because this thing exists. So, but if I change this one to, let's say, green, and I click on send, now you can see that it returned me the new shirt, which has a new ID, which is number 5. And the status code here is 201 created. And let's take a look at the response header. There is a new key here. It's location. And this points to the URL that can be used to retrieve this newly created shirt. And let's actually try that. Go back to get a shirt here and put number 5 here. Click on send. Now we actually can receive the new shirt. Okay, that's everything I want to cover in this video. In the next video, we are going to extract the validation out with ActionFilter. And I'll see you in the next one. In the previous video, we have implemented this create shirt endpoint. And we have 2 validations here, which is inside the action method. It is okay to have validations inside controller action method, but it's better to extract this out into ActionFilter. You have already learned creating a ActionFilter, so I highly recommend you to pause the video right now. Try to create a ActionFilter for validating the shirt object, and then come back and verify whether you have done it correctly or not. Okay, I think you have already done it, and I'm going to implement the validation. So first of all, let's go to Solution Explorer, and then let's go to our filters folder here, and I'm going to add another class, and I'm going to call it shirt validate create shirt filter attribute. And over here, we're going to derive from the action filter attribute. Now we are going to override the onAction executing method here. And we're going to go to our controller and copy the validation over. I actually cut this over and let's comment this out for now. First of all, let's get our shirt. So I'm going to say context.actionArgument. And what is the name of the parameter? It is shirt. Let's go back and just double check. So you can see that the name of this parameter is shirt. Therefore, we can use shirt over here to get the shirt. And we're going to convert this into a shirt. And first of all, we're verifying if the shirt is null. Then what we're going to do is we're going to say context.model state. So we're going to add a error message and model error. And here I'm going to say, just say shirt. And we're going to say shirt object is null. And I'm going to copy the code over from the filter that we have implemented in the past. And here the status code is correct because the parameter in the HTTP request is incorrect. And we are going to short circuit the filter pipeline. Okay, so we have done our first validation. Now, if the shirt is not null, then we're going to do our second validation. Okay, so let's copy this over here. And then let's change this part to include everything here. So copy and paste this over here. We're not distinguishing which one is incorrect. So I'm going to say shirt. And then we're going to say shirt already exists. That's the error message. And again, this is a 400 bat request, and we're short-circuiting this. So that's how I implement it. And I can copy this over and paste it in the shared controller right over here. And we don't need to do any validation inside the action method, which makes this whole thing tidy and clean. And it also follows single responsibility principle. Okay, so let's give it a try. When we just run it, we have 4 different shirts. And again, this one is yellow. So let's actually just make sure we're trying to cause an error. So I'm going to remove the shirt ID. And these 4 fields are the same. Therefore, it's going to create an error. And we can see that 1 or more validation errors occurred. Shirt already exists. So we have this error message beautifully formatted and returned to us. And let's just make sure that everything still works if we follow the Sunny path. So let's change this color to purple. And I'm going to click on Send button again. And we successfully got our 5th shirt. And we should be able to just run this get query to return the 5th shirt, which is correct. And if we run this, getting all the shirts, we should be able to see 5 shirts. This is the new shirt we added, which is the purple one. Okay, that's everything I want to cover in this video. This video serves as a practice for creating an action filter for validating purpose. Okay, I'll see you in the next one. In this video, let's work on implementing the update shirt endpoint. And for that, let's create the update shirt method in the shirt repository first. So let's go to our shirt repository and let's add a static method for updating the shirt in the memory repository. So what's going to be passed in is a shirt. And first of all, we will need to retrieve from the data store the shirt to update. And we're going to say shirts.first, and it's a x goes to x.shirtID equals to shirt.shirtID. So we are not using first or default because we're going to validate this shirt object in the controller first before we actually execute this method. So to update it, we can choose to use AutoMapper, but because this is just an in-memory database for learning purpose, I'm not going to use the AutoMapper here. So we're just going to update the properties one by one. This is actually everything we need to do here. And let's go back to the shirt controller and let's work on the update shirt action method. So first of all, we'll need to pass in a shirt object as well. Okay, and our first validation is to make sure that ID is the same as shirt.shirtID. If it's not the same, then we're going to return a bat request. And then we're going to use shirt repository and just update the shirt. And for return type, usually we return no content, and no content is 204. Right? For update, if there's nothing wrong, we're going to return no content. Where seems to be done, but there's just one thing. What if the shirt is deleted from the data store before we execute this update shirt? We can try to verify whether the shirt is deleted or not just before line 42, but there's nothing we can do to prevent a deletion that happens in between. So therefore, here we'll have to use try catch. And we don't need to worry about what's the type of the exception, because here we're going to check whether the shirt still exists or not. Okay, so if the shirt does not exist anymore, then what we're going to do is we're going to say returning not found. If the exception is thrown because of anything else, then we just throw this exception out, which is going to cause a HTTP 500 internal server error. So that's a generic error for anything that is unhandled. Again, the reason why we're checking this is because we got exception, and that exception is caused by someone deleted the shirt just before the update shirt is executed in the repository. Okay, I think we're ready to give it a test. So let's run the web API and let's bring our Postman. First of all, let's read all of the shirts. Click on the send button. We have 4 shirts. And let's copy this one and paste it over here. Let's do a price update. So this is a sunny pass testing, just to make sure that everything still works. We are seeing this error. Why is that? It's because I forgot to update the ID here. So this ID and this ID does not match. That's why we're seeing that. Okay, and we're going to use the same ID, clicking on the send button again. Now we see 204 no content. That means we have already updated our price on shirt number 4. Let's read all of the shirts again. Scroll all the way down, and we can see the price is updated to 35. Okay, let's go back to update shirt. Let's cause the second error, which is basically when the shirt doesn't exist. So let's click on the send button, and now we can see not found, right? So this error is caused by either someone deleted the shirt, or the shirt doesn't exist in the database in the first place. Anyway, it's the same type of error. Okay, so let's go back to our Visual Studio. There's one thing we need to do is for this update shirt action method, we need to validate the ID. What if the ID is smaller than 0, right? Less than 0. So we will need to actually use this validate shirt ID filter on the update shirt as well. This time, if the ID doesn't exist, it's going to give us a shirt doesn't exist error, which is a 404 not found. Anyways, so let's run the web API again and let's test this. So this time it's going to give us a different error using the same data here. Now you can see shirt doesn't exist. We're using our ActionFilter for validating the shirt ID. Right? And of course, if we use -1, for example, we're going to get shirt ID is invalid. So that's why when I created this shirt ID validation filter, I didn't call it validating get shirt by ID. I'm just call it by generic name. We're just validating the shirt ID. Before we are done with the update shirt, we need to create a action filter to validate the ID for this. So let's go ahead and create another filter, and let's call it shirt _ validate update shirt filter attribute. Again, deriving from action filter attribute, and we're going to override the on action executing. So first of all, we're going to get the ID. I'm going to say context.argument. Right, we get the ID, and then we're going to get the shirt. So action arguments, and here is shirt. So we're going to do the validation. Right? We're going to cast this to integer with a question mark, and we're going to cast this to a shirt. Import a namespace for the shirt class, and then if shirt has value, and at the same time if shirt is not now, then we're going to see whether the ID is the same. And if ID is not the same ID as the shirt ID, then we are going to, let's go to here and copy this, and we're going to say shirt ID is not the same as ID, returning a HTTP 400 BAT request. That's it. Let's copy this over to the controller, and let's decorate this with this new attribute, and we don't need to do this anymore. Let's run the test. All right, so let's make this one 4 and make this one 3 to cause that particular type of problem. Click on send button. We can see that the shirt ID is not the same as ID. The field is shirt ID. So when we see this error message, we know that our action filter is actually working. And actually, let's test actually updating this price to 60. It's sunny pass testing, just make sure everything is still working. Okay, 204 no content. Going back, run this, get all the shirts. we can see the price is updated, 60. Okay, that's everything I want to do in this video. I'll see you in the next one. In this video, we're going to talk about exception handling in Web API endpoints. So previously, we worked on the update shirt endpoint, and we're using the try catch directly in the action method. This works perfectly, except that it's not that clean because the exception handling can be actually handled in exception filter, leaving the endpoint action method itself clean and tidy and follows the single responsibility principle. So therefore, in this video, let's use exception filter to handle the exception here. So let's go to the filters folder and create a subfolder. And let's call it exception filters. We can create another subfolder and call it action filters. And let's move these attributes because all of them are action filters. So let's move them over to the action filters folder and let's adjust namespaces for moved files. Click on yes. So let's go to the exception filters folder and create a new class. And let's call this class shirt _ handle update exceptions filter attribute. And this should derive from the exception filter attribute. And inside here, we can override the onException method. Within here, first of all, we need to get the shirt ID. Because if we go back to the shirt controller, you can see that when we catch the exception, we're trying to use the ID to see whether shirt has been deleted or not. So therefore, let's go back to our exception filter. First of all, we need to get the ID. So context dot, you can see we don't have the action argument anymore. So how do we get the ID of the shirt? Although we don't have the action arguments, we do have something that is called raw data. And from raw data, we can actually get the ID. We can say raw data dot values. And here we have a list of value and we can just provide the key. And the key here is actually the name of that parameter. This would return us a object and it's actually a string. So we're gonna say str shirt ID equals this and let's convert this to a string. And once we have that, we can then use try parse. So integer try parse, we're gonna parse the shirt ID to a integer. So just like that. And inside here, we're going to do the same validation. So let's go to the shirt controller. Let's copy this and go back to the exception filter here. Let's say if shirt ID, we're going to use the same logic here. And then we're going to pass the shirt ID inside here. And once we found the shirt ID doesn't exist, that's where we're going to short circuit the filter pipeline. And the way to do that is the same as the action filter. So let's go to any of the action filter. Let's copy one of them and let's go back to the exception filter, paste it over here. And we're having a problem with the shirt ID, right? And we can say shirt doesn't exist anymore. So basically shirt is deleted. And then the status code here, of course, is going to be not found. So 404 not found. And this result should be not found object result. So that's everything we need to do in the exception filter attribute. And now let's copy this filter and use that in the shirt controller. First of all, let's do control dot to import new namespace. And then let's put this new exception filter over here. And let's remove the try catch because we don't need it anymore. We already have the exception filter to handle the exception. And this makes our action method clean, tidy, and following the single responsibility principle. We still keep the ID over here because the ID is needed in this filter and perhaps in this filter as well. So let's give it a test to make sure that everything still works. Let's run our web API. Okay, let's bring our Postman and we're looking at the update shirt. So we're having number 9 here. If we click on the set button right now, I know the validate shirt ID action filter attribute will be actually triggered. So let's click on it. You can see that it says shirt doesn't exist, right? It doesn't say shirt doesn't exist anymore. So this is the validate ID ActionFilter attribute. So in order to actually trigger this problem, let's comment this filter. Because in real world scenario, the exception filter will only be useful when someone actually delete the shirt right before the method is executed, right? So in order to cause that error, let's do not handle the shirt ID problem. Let's simulate that problem by using a big ID, which doesn't actually exist in the database. So let's do that test. Click on this. And the thing that we want to see is this error message in the exception filter. We're looking for this message, shirt doesn't exist anymore. So let's go over here. We're having a very big ID, number 9, which doesn't exist in the in-memory data store. So click on the send button now. And now we're seeing the shirt doesn't exist anymore. Status code 404, status code 404 not found. Okay, let's go back to our shirt controller. Let's uncomment this. That's everything I want to show in this video, and I'll see you in the next one. In this video, let's work on the delete shirt endpoint. Again, first of all, let's go to the shirt repository and implement the delete shirt method over there. So here, adding another public static method and returning nothing. So we're going to delete shirt. Visual Studio already anticipated I'm going to work on this one. Unfortunately, we're not passing in the shirt object, but we're passing in the shirt ID. First of all, we're going to find the shirt. And if we actually found it, then we are going to just remove the shirt from the shirts list. Just like that. Of course, you might be thinking, what if the shirt doesn't exist? That's where we are going to use the validate shirt ID action filter attribute. So let's go back to our shirt controller. So first of all, let's actually apply the validate shirt ID attribute. And over here, we can just say shirt equals shirt repository. We need to actually retrieve the shirt first, because usually developers like to return the shirt that is deleted over here. It's kind of like a convention. So that's why we retrieve the shirt first. And then after that, we're going to use the shirt repository to delete the shirt by the ID. And that's everything we want to do in this method. I just want to mention something that usually in a production system, people like to implement a soft delete. Whereas here, I just want to complete the CRUD operations by not implementing the soft delete, but implementing hard delete. Okay, so in the repository, instead of mark a shirt as deleted, it actually removed it from this in-memory data store. Anyways, let's give it a try and see whether it works or not. Let's bring up our Postman. Let's go to the delete shirt endpoint. And if we are supplying something that doesn't exist, in this case, we only have 4 in the in-memory data store. So clicking on send button, shirt doesn't exist. This is the doing of the shirt ID validation filter attribute. Instead of using 5, let's use 1. And then let's delete the first shirt. Click on the send button. Okay, now it actually returned us the first shirt. And we can see that we have 200 OK. And if we go to read all shirts, click on send button, you can see that the first shirt is number 2, followed by 3 and 4. We're missing number 1. So number 1 is the one that we just deleted. And that's everything I want to cover in this video. I'll see you in the next one.